said facts don't fit the theory. Change the facts.
Woohoo! Or change the theory. But just to argue. This one is just to quickly go over the anatomy of the respiratory system. So we can let's start in the nose. This is cool to start at. So the nasal cavity, please notice with the nasal cavity that it is continuous with the mouth. I think we all know that when we've ever, stuck something down and had to swallow or spit. Continuous, or if you laugh, orange juice has come out my nose before. And these guys, which are, you don't see them in many diagrams, but your connection and drainage from sinuses, which is kind of cool. This is called your hard palate. And you'll push up against your hard palate. And back here we have both the pharynx is just the real far back part of your throat. It is right before the larynx. Now, the larynx is otherwise also called your voice box. So I added that to the diagram, this arrow here, your voice box. And hard cartilage on the way around the voice box. And when you swallow, it's your larynx that actually moves up, and it pushes the glottis, the epiglottis over the glottis. Now the very top of the trachea is called the glottis. Glottis, and we learned that epiglottis with the digestive system is a flap that would cover your breathing tube, your trachea, when you swallowed. And sometimes when you're drinking, you can see that larynx for every swallow moving to cover up with the epiglottis, which is kind of cool. So then there was the question, why do boys have Adam's apples? Traditionally, hopefully you know what you all know what an Adam's apple is. Traditionally, here, I got a picture. Here's the Adam's apple. And in puberty, the larynx, or that voice box region, grows larger in males than in females. It doesn't mean that there are no women with Adam's apples. And the name Adam apple does come from the biblical story when Adam ate the apple, when an round apple caught in his throat. He shouldn't have eaten the apple, and our life is hell because of it. But that's just a story. And remember that Lady Eve gave it to. Anyway, so right at puberty, the larynx starts getting larger, and these are muscles in your voice box. So the larynx is for speech, and they vibrate. You control the air going in and out. You can see the vocal muscles here. And a larger chamber where these muscles vibrate, the deeper the sound. A smaller chamber, a higher pitch sound. So female voices tend to be higher pitched. It doesn't mean they can't be deeper, especially if smoking and stuff can stiffen these and also make them sound deeper than they are, and you get that raspy voice. James Earl Jones probably has a very large larynx because he's a very deep natural voice. So let's continue past the larynx, or the voice box. All of this is made out of cartilage, nice and hard. You can feel the rings of cartilage. You want to prevent it from crushing down. You don't want to do anything that would stop airflow. And so you've got your trachea. It's going to branch into bronchus, your large tubes, and then they continue to branch into bronchioles, and they keep branching and branching and branching. Now, these are lined with mucus and cilia, and they're constantly beating and pushing debris, dust, dirt, viruses, bacteria up and out, and you will maybe snort it up and blow it out your nose. You might gag it up and spit it out your mouth. But more likely, it'll come up right about here, and you'll swallow it down into your stomach, and the acid will destroy anything that's there. Now, we end further down here it all ends at the alveoli, these air sacs. Now, these are incredibly small air sacs, and they have no cilia. Since they have no cilia, there's no way to empty any material that gets in there. So they're very susceptible to any kind of particulates, coal, mining dust. Potters get silicon dust. The dust from pottery is very fine. Even baby powder, some people use so much of it, it's like a cloud around them. There's no way to get things out of the alveoli. Now, you've got white blood cells that will patrol the capillary beds, and they'll try to engulf some, and they'll do their best to get some out. But the air currents are going very slow in here, incredibly slow in here. So you don't have cilia, but you also don't have high airflow to help get any of that out. Now these air sacs are so small, and I told you that gases diffuse through liquid. If this was just water on the inside of here, they're so small that the surface tension of water would collapse them. Hopefully in chemistry you did a lab. How many drops of water can you fit on a penny? And you would get this big looking bubble of water on that penny, and you'd count, and this surface tension of water. So the surface tension of pure water would cause these air sacs to collapse. And then you had to do how many drops of water on a penny after adding a drop of soap to it. And then you could get like hardly none. It broke the surface tension very easily. So the moisture that the gases diffuse through is a mixture out of soap, but something close, because soap is nonpolar, water, lipids, and proteins, and the functional groups on those proteins will be also nonpolar to reduce the surface tension to keep the air sacs open. Now, which is kind of cool, it all comes together in Mufasa. However, that you can get all kinds of lung diseases. The big one is pneumonia. When this fills up, sometimes when you get fluid and stuff in here, mucus or just leaky capillaries because of an inflammatory response, and you get too much liquid, these guys will actually close on each other and then pop open and close and pop open. And what you get is something called crackling, and you can hear it. If you ever wondered what the doctor's listening for, and you can say if you have pneumonia or not. I hope you guys can hear this. Let me hit play. This is the crackles. So those hard pops you're hearing as someone's just seated and breathing are the ear sacs actually popping back open after collapsing together. One more time. So this is also sometimes called rales. So if you hear rales, you're going to be diagnosed with pneumonia. So I wanted to show you a healthy lung. We've only got a few more seconds left, but you can see how this branching and branching, it makes a very spongy appearance. And these are bronchioles, and the actual alveoli are so small, incredibly small. You can't even see this is a cross section of a nice healthy lung. It's called gross anatomy. It's post-mortem, obviously. This person's no longer alive. But you can see kind of the structure of the larger bronchioles branching and branching and branching, and they terminate at these air sacs. And what lecture on the lungs would not be complete without a showing a smoker's lung. So this is the gross anatomy of a lung suffering emphysema from chronic smoking. So yet another reason not to smoke, independent of what it does to your lungs. We've also learned about what it does to your arteries and veins. So we will never, ever smoke. Ever.